All right, hi folks, this is Larry Mussolino. I'm recording a video for Objective 14 in ALEX. And you might notice Objective 14 is working with what are called radical equations. So these are going to be equations that have square roots in them. And we're going to want to solve for x, which means get x by itself. But in order to do that, we're going to have to get rid of square roots. And the way we're going to do that is to get rid of a square root, we can square both sides of an equation. Because it turns out when you square a square root, because those are opposite or inverses, they'll cancel each other out. So let's do a quick example to get started here from ALEX. So here's an example that says the square root of x equals 9. All right, well, remember, I want to get x by itself. Right now, x is kind of stuck underneath the square root symbol. So if I'm going to get x by itself, I really want to get rid of that square root. So I'm going to square both sides. Well, squaring a square root cancels out. So this square root and this square cancel, leaving me with just x. And on the right side, I have 9 squared, that's 81. So this answer is just x equal 81. Now, it's going to be important when we start doing more of these examples, you must check your answers in these kinds of problems. Because what can happen is, in other examples, you might end up with a solution that leads you to take the square root of a negative number. So let me check our example here. The square root of x equals 9. We came up with x equals 81. And the square root of 81, of course, is 9, so this checks out. This is a little bit of a more simple example, but in later examples, it is going to be important to check your answers. Remember, if you take the square root of a negative number, you get an answer that's not a real number. Now, we're going to see in a few minutes there is a way to take a square root of a negative number using something called imaginary numbers. So we'll get to that in just a minute. Also, remember that when you take a square root like this, the answer always has to be positive. So you might see in ALEX an example that asks you to solve an equation. Let me try to find another example here where you might end up with a negative number. Well, it looks like I can't. Here it is. This is a good one. I'm noticing here this one says the square root of u equals -8. Well, if I take a square root, the square root of any positive number, I must get an answer that's positive, right? I cannot get an answer that's negative here. So for this problem, the answer is going to be no solution. There's no way to take the square root of a number and get an answer that's negative. So this answer, where they have the square root equal to -8, the result here, or the answer is no solution. All right, let us go and do a few more examples of solving some examples here. All right, well, in this one, they say solve this equation for A. Now, remember, when you see solve an equation for A, really that's asking you to get A by itself on one side. All right, well, right now, A is stuck underneath the square root symbol. The first thing I'm going to do is get rid of the square root. The way I'm going to do that is square both sides. Right, and a square root and a square are inverses, so they cancel out. So now I have A over 3 equals B squared. One more step, because I want to get A by itself, I want to get rid of this division by 3. So I'm going to multiply by 3. Of course, I have to do that on both sides. Here on the left side, 3 on top and 3 on bottom cancel out. So I'm left with A equals 3B squared. All right, so in this example, because we wanted to get rid of the square root, we ended up squaring both sides of the equation. Okay. Let's take a look at another example here. All right. So this one is again, an equation that has a square root. Now for this one, there's going to be two steps I'm going to follow. Step one is going to be to get the square root part all by itself on one side. So I want to isolate the square root part all alone on one side of the equation. Then I'm going to want to get rid of the square root. So that means I'm going to square both sides. All right, so let's follow these steps. Here's the equation they're giving us. Well, the first step is I want to get the square root by itself. So let me get rid of that addition of 12. So I'm going to subtract 12 from both sides. And this is going to give me the square root of v minus 7 equals a negative 7. Well, I'm going to stop right here. I'm not going to do anything else because, again, I have a square root with an answer being a negative number, which is impossible. I can't take the square root and end up with a negative answer. So on this one, there's no solution. Okay. Now, if this had been a positive number here on the right-hand side, I would be squaring both sides to get rid of this square root. But in this example, I'm going to stop because I know I can't take a square root and end up with a negative answer. All right. Let me, what if we take a look at another example here? All right, let's try this one. So on this one, they're asking us to solve this equation. And again, I'm noticing there's a square root all by itself on one side. Well, I want to get rid of the square root. So my first step here is going to be to square both sides. So I'm squaring both sides. The square root and the square cancel out here. So I'm left with u squared equals 11u minus 30. All right, well, now this is leading me to a quadratic equation. And for a quadratic equation, remember the first step is you want to get the equation set equal to 0. So here's what I'm going to do. I'm going to subtract 11u from both sides to get started. That's going to give me u squared minus 11u equals negative 30. One more step, I want to get a 0 on this side. So I'm going to add 30 to both sides of this equation. Again, my goal here was to get the equation set equal to 0. Well, subtracting 30, adding 30 cancel out, so it does get me a 0. So now I have this quadratic equation. I'm going to write it up here, u squared minus 11u plus 30 equals 0. Well, you probably remember when solving a quadratic equation like this, once you have the equation set equal to 0, you try to factor. So I'm going to try to factor this left side. I'm going to put a u and a u in front. And it looks like I'm going to need two subtractions inside, right? Because this number is positive here, but this is a negative in the middle. So let me see here. I need two numbers that multiply to 30, multiply to positive 30, but add to negative 11. So let me list out the possibilities. So here are numbers that multiply to 30. This is going to be 1 and 30, 2 and 15, 3 and 10, and 5 and 6. It looks like 5 and 6 is going to do the job, right? Because if I add negative 5 and negative 6, I get this negative 11 here in the middle. And if I multiply negative 5 times negative 6, I get 30 there. All right, then you remember you set each one of these parentheses separately equal to 0. So over here, I'm going to add 5 to both sides. That's going to get me u equals 5. And over here, I'm going to add 6 to both sides. That's going to get me u equals 6. You might remember when you solve quadratic equations, it's very common to end up with two solutions here. All right, but I'm not done yet because I have to check my answer, my solutions here. I can't just assume that u equal 5 and u equal 6 are both valid. The reason is one of these solutions or even both of these solutions might not be valid when I go to plug them back in the starting equation. So let's do a check. First, let's check the solution u equal 5. So I'm going to go to this equation, and wherever I see a u, I'm going to replace it with 5. So this gives me 5 equals the square root of 11 times 5 minus 30. Well, 11 times 5 is 55. And then 55 subtract 30 is 25. And of course, the square root of 25 is 5. So this checks out. So we just figured out that u equal 5 is valid. All right, but we also have to check the other solution. So let's also check u equals 6. See if that works out. So again, I'm going to plug 6 into the original equation in place of u. So we end up here with 11 times 6 is 66. But 66 minus 30 is 36. And you can see this is going to work out to the square root of 36 is 6. So 6 equals 6. So u equals 6 is also a valid solution. So there's really two answers here. So this problem had two solutions, u equal 5 and u equal 6. But again, you must check, because it could turn out that one of these solutions or even both of these solutions might not be valid when you plug them back in. All right, let me move on to an example that involves taking the square root of negative numbers. All right, so let me come to this example here. Let me get an example that is the square root of a negative number. Here we go. All right. Well, you might remember that we said earlier in the course, if you take the square root of a negative number, you end up with an answer that's not a real answer. And that's true. But we have an alternate method here to handle this. We use something called an imaginary number. And an imaginary number is written using the letter I for imaginary. And it's defined to be the square root of negative 1. And you might say, well, you can't really take the square root of negative 1. Because the square root of negative 1 is asking you what number times itself equals negative 1. There is no such answer to that. That's true, but we can come up with an imaginary number that's defined as the square root of negative 1. So here's what we do. Whenever you have a square root underneath, whenever you have a negative number underneath the square root, break it up to be a number times negative 1. So instead of writing negative 4, I'm going to rewrite it as 4 times negative 1. Well, now I'm allowed to break this up into two separate square roots. But the square root of 4 is 2, and the square root of negative 1 is I. So this is the answer to this problem, 2I. And notice the instruction said, write your answer in terms of I. That means your answer should have an I as part of the answer. All right, so what this says is when you want to take the square root of a negative number, let's say the square root of negative 25, always break it up to be a number times negative 1. The reason for that is when you break it up into separate square roots, you're going to end up with the square root of negative 1, but then you'll replace that with an I. And in this example, the square root of 25 is 5, so this answer would just be 5I. All right, we're going to be using this imaginary number in the next few objectives. For example, when we go to solve quadratic equations, we might end up taking the square root of a negative number. All right, let me do a few more examples here. Let me come here to adding or subtracting what's called complex numbers. All right, so what is a complex number? Well, we just said that I is the square root of negative 1, and we call this an imaginary number. But we could have a quantity that's a sum of a real number plus an imaginary number. Let me give you an example. How about if I take the number 5, of course that's a real number, and I take 2I, that's an imaginary number. Anytime I have an I, that makes it imaginary. But if I put together 5 plus 2I, we call this a complex number. So a complex number is made up of a real part, that's a number like 5 or 7 or negative 2, and an imaginary part that has an I in it. Well, in this example, they want us to subtract these complex numbers. So here's what they're giving us. Now, when it comes to adding or subtracting complex numbers, you can almost think about this like combining like terms. So what that means is you're going to add together any numbers and then also add together any imaginary parts. For example, if I had, let's say, 5i plus 3i, this is like terms. I can add this and get 8i. Right? This is just like, if I had 5x plus 3x, the answer is 8x. In the same way, 5i plus 3i would equal 8i. All right, first step here, let me take this subtraction sign and distribute it inside the back parentheses. So this is going to be the negative of a negative 1, which flips to be positive 1, and the negative of 2i is minus 2i. Now I'm just going to combine like terms. Well, I have a 4 plus 1, so that's a 5. Then I have a negative 6i minus 2i, which is a minus 8i. All right, so you can see this really just boils down to combining like terms. You can think of I as like a variable, and we know I is defined to be the square root of negative 1. All right, let me do one more example of working with complex numbers. Here's a topic on multiplying these complex numbers. All right, let's take a look at this one. Now, one thing I have to mention to you is we know that I is defined to be the square root of negative 1. It turns out if you end up with I times I, well, that's really I squared. That works out to just be negative 1. Okay, so I is the square root of negative 1, and I squared is equal to negative 1. These are on the reference packet in case you forget. All right, so let's go do this multiplication. Well, this is a multiplication that's just like a FOIL kind of multiplication. So for the FOIL multiplication, here's what I'm going to do. I'm going to start out taking this 2 and letting it multiply the negative 2 in the back. So that's going to be a negative 4. Then this 2 is going to multiply 6i. Well, that's going to be 12i. Then I'm going to come back and take this negative 4i and let it multiply negative 2. So that's minus 8i. And finally, this negative 4i multiplies the 6i. That's going to be minus 24. But I just multiplied I times I, which is I squared. All right, well, one thing I remember is that I squared is negative 1. So I'm going to replace that I squared with negative 1. Now, let me just try to clean this up a little bit. Let's see, here in the middle, these are like terms. I have 12i minus 8i, so that's 4i. And back here, I can think of this as a negative 24 multiplying a negative 1. That's positive 24. One last step, because I have a negative 4 plus 24, that's 20. So the final answer here is 20 plus 4i. All right, so in this example, they asked me to multiply these two complex numbers. So I had to remember this was a FOIL kind of multiplication. And I also had to remember that if I come across an I squared, I'm going to replace it with a negative 1. All right, again, we're going to use these imaginary numbers and complex numbers in objectives 15 and 16. Let me see if there's anything else. I think we've done most of these. Let's do, I don't think we did this one yet. All right, let's take a look at this one. All right, so, this again is a square root kind of an equation. But remember, for this kind of an equation, I want to get rid of square roots. So what I'm going to do to get started here is I'm going to square both sides. Because remember, squaring both sides will get rid of the square root for me. So let's square both sides. Okay, on the left side here, I have on the right side, I have a square root and a square. Well, those are inverses, so they cancel out. So I just get 10y squared minus 2y minus 24. On the left side here, I have 3y squared. But 3y squared really means 3y times itself. Well, 3 times 3 is 9, and y times y is y squared. So this is a 9y squared over here. Well, notice this is a quadratic equation. And for a quadratic equation, first step, let's get the equation set equal to 0. For that, I'm going to subtract 9y squared from both sides, so I can get a 0 on the left side. 9y squared subtract 9y squared is a 0. Here I have a 10y squared minus 9y squared. That's just 1y squared. All right, now I have a quadratic equation that's set equal to 0. The next step is factor the one side. All right, let me try to factor this side. All right, I know I need to put a y and a y in front. I know these signs inside are going to be different because I have a negative 24 back here. Anytime this constant here is negative, it tells you different signs. All right, so I need two numbers to multiply to 24, negative 24, but add to negative 2. All right, well, I think if I use 6 and 4, that's going to work. And I want to put a negative 6 here and a positive 4. Let me double check and see if this makes sense. Well, 4 times negative 6 would get me the negative 24. And 4 plus negative 6 would get me the negative 2. So I think that factoring looks good. The last step now is to set each one of these factors separately equal to 0. So let me do that. I'm going to break this up and make it y plus 4 equals 0 and y minus 6 equals 0. All right, here I'm going to subtract 4 from both sides. That's going to get me y equals negative 4. Over here, I'm going to add 6 to both sides. That's going to get me y equal positive 6. All right, but now I've got to check my answers. Remember, for these kinds of square root equations, you must check your answers. So let me go up here, and I'm going to do a check for each one of these two solutions. Again, it might turn out that none of these are valid. It might turn out only one is valid. It might turn out both are valid, but I got to do the check. So let's check y equal negative 4. All right, so here's what I'm going to end up with. 3 times negative 4 equals the square root. I'm going to stop right here because this left side is a negative 12. And I know I can never take a square root and get a negative answer like negative 12. So that tells me that y equals negative 4 is not valid. So right away, I'm going to get rid of that guy. All right, let's check the other solution, y equals 6. All right, so this is going to be 3 times 6 equals the square root of 10 times 6 squared minus 2 times 6 minus 24. All right, well, on the left side, 3 times 6 is 18. On the right side, 6 squared is 36. 36 times 10 is 360. Minus 12 minus 24. All right, let me keep going. Let's see, 360 subtract 12 is 348. And then I'm going to do 348 minus 24. That is 324. And if I take the square root of 324, it does equal 18. So 18 equals 18 here checks out. So that means y equals 6 is the only solution. So the only solution on this problem is y equals 6. We found out that y equal negative 4 was not valid. Now, by the way, it could be that a negative number is a valid solution, but in this example, it so happened that negative 4 was not valid. All right, so again, just a reminder that you must check your answers in these radical equations because some of your answers might turn out to be invalid. All right, hope this is helpful as you're working in Objective 14.